CircuitPython students, powerful Pythonistas, and magnificent makers, it's Prof G here to show you how to set up the PyCharm Python editor to work with CircuitPython and your microcontrollers. Now this will take a little bit of initial setup work, but once you do this, I think you'll find that PyCharm is super helpful with better code completion and error reporting that make it easier for you to catch the sort of simple mistakes that often trip up folks that are new to CircuitPython coding. Now, after we perform the software install, we're going to create and configure our first PyCharm project so that it works with our Pico and uses CircuitPython. Now, once we do this, we shouldn't need to do this again. We're going to use that same project throughout this course. The project just has some configuration options for working with PyCharm and CircuitPython. All of our code files are actually going to be saved outside of this project. But if you ever need to create a new PyCharm project with a different configuration, you can always go through the steps at the end of this lesson. I'm going to assume everyone here has already upgraded their board to the latest version of CircuitPython, and they've installed CircUp. If you haven't done those things, start with the earlier lessons in the playlist. Now this will take a little bit of initial setup work, but once you do this, I think you'll find that PyCharm is super helpful. So here's what we'll do. We'll install our upgrade Python on your computer, then we'll install a program called Tio, which we'll need to link PyCharm with our CircuitPy board. We'll download and install PyCharm CE, that's the free version of PyCharm. Then we'll configure PyCharm and create a PyCharm project for CircuitPython. We'll set the project up so that it saves our program to the CircuitPy board, not our computer. Remember, we want our programs to run on the board, not our Mac or PC. We'll configure our project so that it recognizes extensions in the CircuitPython programming language, so that's stuff beyond basic Python, and we'll do this by adding something called the CircuitPython stubs to our project. Once we do all that, we'll finally be ready to start our coding lessons. So there are a few steps in there, but once we do this, most of this work won't need to be repeated, so on with the setup. In the prior lesson on CircUp, we installed the latest version of Python on your computer. If you didn't go through those steps, you can check the version number by launching the terminal program. Mac users type Command spacebar to open Spotlight. Type terminal and press return. Windows users, you should find a terminal under the start menu. Otherwise, you can download a terminal from the Windows Store. Now you can check to see if Python is installed and which version by typing Python 3 space -- version and press return. Either it says there's no Python 3 or it gives you a version number, and you can double check this version number against the version that you'll see at python.org, clicking on download and looking at this number. If this number is greater than the one that showed up in your terminal, or if terminal said Python 3 wasn't installed, follow the steps to download the version of Python you need for your computer and install it. Now back in terminal, if you just installed or upgraded Python, you can rerun the version command we typed earlier. Pro tip, simply press the up arrow key on the keyboard and the prior command that you entered in the terminal will reappear. Press return to execute it, and everyone should now see a Python version installed. Your version is probably newer than what I'm showing here. Now we have another issue that we need to deal with before we install PyCharm, and we only have to deal with this once during installation. Normally when you run Python code in PyCharm, it runs on your computer, but with CircuitPython, we're running code on our CircuitPy board. Now while PyCharm has an area that shows the results of an executing program, it's called the console, that console only shows the results of code that runs on your computer, not on the separate CircuitPy board. In fact, quick and important aside, I've seen lots of experienced programmers simply assume that they can press the PyCharm play button to execute code. After all, that's what they've done when running programs on their computer in the past, but this will not work with a microcontroller board. Pressing the run button brings up the run pane, which we never use when working on a board like the Pico. The run pane does not show what's happening on our board, only our computer. So if you tap this button or use the shortcuts like Control R on Mac or Shift F10 on Windows, you're just going to see the run pane show up filled with a bunch of weird errors. If you do this by accident and close it, the standard PyCharm run procedure does not work. We'll never use the run pane when working on an external microcontroller like the Pico. Now what we're going to do to overcome this is we're going to install a program called Tio, spelled like uncle in Spanish. That stands for Terminal I/O or Terminal Input Output, and we'll run Tio from the terminal pane in PyCharm. This is a separate area below our code in the same location where the console is, and Tio will connect to our CircuitPy board, and it will show any output from the executing program, or it will report any runtime errors. We can even use Tio to run something called a REPL to execute code line by line, and we'll talk more about that in a future lesson. So we're going to use the terminal program to install Tio, but in order to install Tio, we first have to install yet another program to install it. Now, since I'm using a Mac, I'm going to install a program called Homebrew, sometimes called a brew, and that will let us install Tio. Windows users need an installer called msys2. Now, I will provide some Windows installation information, but even better, one of my teaching assistants regularly edits a Windows installation document, which you can find at this URL. And also note that you can search for the Adafruit Learn Guide for PyCharm and CircuitPython. Both of those will likely be a real big help if you're a Windows user. If you have Windows, definitely consult this Learn Guide, but your install is going to go something like this. Search online for GitHub, Tio Terminal IO, and you should see this GitHub page. Click this one that says Tio/Tio, a serial device IO tool. Then scroll down to find the installation guide. You can see the area for Windows. Click MySys2 and then follow those installation instructions. And after you've installed MySys2, then back here in the Tio install guide for Windows, copy this command, paste it in your terminal. Make sure you've done any other steps that are mentioned in the Learn Guide, and meet us back here after I've done the Mac install. Now for Mac folks, we want to open a browser and go to the very unusual URL, brew.sh. There's no .com in there. And you'll see this big line under Install Homebrew. We can copy this entire line here. So this is the command we want to enter in the terminal. Just click on the little clipboard icon to the right of the line, and then I'll Command Tab over to get back to the terminal program. I'll press Command V to paste in what I just copied. Press Return. You might be asked to enter your Mac's password. You won't see anything as you type. Press Return when you've entered it. Then just follow any prompts that show up on screen. So you might be asked to press Return again at different times during the installation process. Sometimes it might look like things have stalled. Don't worry, it's probably fine. Sometimes it just takes a little bit of time to show any work that it's doing. Pay attention to see if there are any prompts in there. Now your install is probably done. This was the case when I first installed Brew. For some reason, when I uninstalled Brew and then reinstalled it just now so that I could record this lesson, I needed one more step. You can see that I jumped the gun and tried to install Tio right after, but I got this message that said command not found. So if you have this message here that says next step, and you might not, copy this line here from eval all the way through the closing double quotes, then paste it after the percentage prompt and press return. And I have another jump cut update in here because some of you might have a message that says run these two commands. Now I got this message when I was trying to do a fresh install on my wife's Mac. Now my wife is not a programmer. Her Mac is more like a brand new Mac since it doesn't have all of the developer stuff that mine has from years of being a programmer. Now regardless of whether you have this warning or the one that I showed earlier or some other warning, do pay attention to the output. Shame on me for not doing this. Most messages in output don't make any sense, but you do want to look at it because up here it clearly says in red, warning, and a path is not your path. If you don't know that term path, it's not super important, but it just refers to the directory or folder structure to get to a file. Instructions on how to configure your shell for Homebrew can be found in the Next Steps section below. And again, sometimes the terms are unfamiliar. The word shell just refers to the program that runs the prompt that you see in the terminal. For Mac, the default shell is called the ZSH shell. That's what we're using at the % prompt, but frankly, that's more than you need to know. What you should do, though, is always look for warnings. Also check out to see if there are any messages or commands just before you hit the % prompt. If there are additional steps to perform, sometimes they show up just before the % prompt. You might see additional errors or warnings in there as well. So if you got these two steps like I'm showing here, just highlight this first line. That's all the characters in this line. Note that this line runs onto two separate lines, but it's meant to be a single line of commands. Again, get every single character you see in here, then copy it and paste it down in the % and press return, and then do the same for the second line, and you should be good to go. And now we're ready to install Tio by typing brew install Tio and press return. My installation took about 4 minutes. And when you're done, you should be back at the % prompt. You can verify the install and get the version by typing in Tio space -- version, press return, and you'll see the version number in there if it worked. You probably have a number higher than mine. Our install is looking good. And you should be able to quit terminal, and now we're finally ready to download the PyCharm program. So in the browser, enter the key term PyCharm, PyCharm, and you should see the first link that shows up is a link to the JetBeans website. So click that. Click the download button. Now we don't want the item that's at the top of the screen. That's for PyCharm, the Unified product. That's the paid version. We don't want that, so keep scrolling. And find PyCharm Community Edition, sometimes called PyCharm CE. That's the free version. That's going to be good for us. Now do make sure you're downloading the right version for your computer. The browser can probably recognize whether you're using Windows or Mac, but you might have a pull-down menu to choose the right version for your version of Windows or Mac. For example, there are versions for Apple Silicon, modern Macs, or Intel Macs, older Macs. If you're not sure which one you've got, head up to your Apple menu, select About This Mac, and under Chip, it probably says Apple, which is Apple Silicon, or Intel, which is the Intel chip. So select the right version before clicking download, then click download. Yours is probably downloading to your downloads folder. Mine will ask me where I want to save this. I'm going to save it on the desktop. When the download's done, why don't you find the file you just downloaded? Safari automatically uncompresses the file. If you downloaded with another browser like Chrome, you probably have to double-click a .zip file to decompress it first. Then double-click the PyCharm.pkg file that you just downloaded. Drag the PyCharm CE icon into the Applications folder. If you open your Applications folder now, you should find PyCharm is in there. Now, I also like to put PyCharm in my dock so it's nice and handy, so I'm going to drag the PyCharm icon into the dock and let it go, placing it right next to my other IDEs. And you can minimize the install window, and you can drag both the .pkg file and this PyCharm CE gray installer icon into the trash, and the installation is done. Now, before we create our first PyCharm project, let's make sure that our board is plugged in. One end into your computer, one end into the Pico. I'm using a Raspberry Pi Pico 2W. Always make sure that you're using a data cable, not a charge-only cable, or things won't work. If you went through the earlier lessons, you probably have your NeoPixel strip attached as well. And if you completed the earlier lesson on installing CircuitPython on your Pico, you should now see a CircuitPy volume appear on your computer. That's your board. Now let's launch PyCharm. Mine is in the dock. The first time you run this, you might be asked if you want to open something that you downloaded from the internet. Yes, you do. So press open, and you see the Welcome to PyCharm window. PyCharm will show your recent work if you have any. Now, a bit of terminology. A project in PyCharm contains configuration information that we need when writing Python code, and this project or configuration information is saved to our computer. Now, when working with CircuitPython, the project configuration information will be saved to our computer, but our code is going to be saved to our CircuitPy board. Now, for CircuitPython projects, our project will include configuration information such as use the latest version of Python 3 that you downloaded, and extend this to recognize CircuitPython basics called stubs. We'll tell our project to add any CircuitPython libraries that we plan to use, and we'll tell the project to save our code to our CircuitPy board, not our computer. That's important because when code is saved on the board, it's going to run on the board. And so we're going to go through and set up our first project with our CircuitPython configuration. One nice thing is we can reuse the project after we set it up and just change the code on our CircuitPy board from lesson to lesson. Now, one weird thing to be aware of, a PyCharm project shows up as a folder, and the project that we're going to be setting up to use CircuitPython will look empty because we're going to save our code to our CircuitPy board. But it's actually not empty. The configuration files that PyCharm uses are hidden, and that's because you'd never click on these files. You do all your configuration from within PyCharm. So if you look in a PyCharm project folder and you don't see anything, don't delete it unless you really want to delete the project and all its configuration information. And if you're curious about hidden files, on the Mac you can toggle hidden files between show and hide by pressing Shift-Command period. Now back to PyCharm. If you just set it up, you've got no projects in PyCharm, so just click the New Project button, and we'll see the New Project Setup screen. Now, unfortunately, this doesn't show you the friendly Finder navigation menu that you usually see if you select a folder to save a file and give it a file name, but this window is doing the same thing that you would see, for example, if you selected Save As on a Mac. Now, the first thing we want to do is to select the folder where we want to save our project. So on this line here that says Location, click this little folder icon off to the right, and we can navigate to wherever we want to save our project. Now, I want to save this PyCharm project into the CircuitPython school folder that we created in an earlier lesson. Now, mine happens to be on the desktop, so I'm going to navigate to the desktop. Then I'm going to navigate inside the CircuitPython school folder. Just double-click to go inside that folder. And I'm going to store my project in a new folder. So I'll click the new folder icon down here on the left. I'm going to give this folder a name, and since it's going to be a CircuitPython project, I'm going to call this cp-project. Then click Create, then click Open, and we're ready to create our project. I've got these default selections here. The interpreter type is Project venv. The Python version is the latest version downloaded to my machine. You should have these defaults as well, but if not, select them now. Then click the Create button, and ho-ho, our project is open. I like to take up the maximum amount of screen real estate, so on the Mac, if you find an empty spot in the window title bar, you can double-click and your window will take up the whole screen. I prefer to do this instead of clicking on the Maximize button because I like to see the menus. By the way, I think this column's too big, so I can move my mouse on top of the separator line and click and drag to shrink it. So let's make some project configuration settings. So to get to PyCharm setting, Mac users, you'll find settings under the PyCharm menu. Windows users, it's probably under the file menu. You'll see a lot of options in the left-hand column. Note that some of the options have expansion triangles next to them. Pointing right collapses the listings below a heading. Click the triangle and it will point down and expand the listing so you can see everything underneath it. Click it again and it collapses and points to right. Double-clicking an item with a triangle will also expand or contract. And the first thing I'm going to do is to change the look of PyCharm. I realize many users prefer dark mode. I have terrible eyesight, so bad that I can't drive, so a white background actually works better for me. Now, if you want to change mode too, you can head to Appearance and Behavior, then click on Appearance, and I'm going to change dark mode to light mode. I also want to make sure that the text is bigger, so I'm going to click on Editor over here on the left-hand side, then Font, and font size 20 should work well for me, and hopefully it'll be easier for you to read too. But pro tip, when you're coding, you can increase or decrease the font size with Shift-Control greater than symbol or Shift-Control less than symbol. Now, another thing I want to do is to make sure that we have an unsaved changes indicator next to the file name in the tab. And to make sure that we have that indicator, we'll navigate to Editor, General, Editor tabs, and we'll make sure that the box is checked that says Marked Modified. By doing this, when you have unsaved changes, you'll just see a little ball next to the file name in the tab. Now, another setting we want is to make sure that PyCharm does not auto-save our CircuitPython projects, and that's because our board will execute any code as soon as it's saved, and we don't want PyCharm's autosave to randomly execute buggy code. So the way we turn off autosave is on the left-hand side here, we find Appearances and Behaviors, and under that is System Settings. Make sure you click it so the options show up. Now look under the autosave options, and the first two options should be unchecked. So no check next to save files if IDE is idle, no check next to save files when switching to a different application or built-in terminal, but do check the box for backup files before saving. So yours should look like this as well. The next thing we want to do is configure this project so that it saves our Python code to our CircuitPy volume, to our board. And we do that by setting something called the project's content root. We're going to do that by finding the project name in the left-hand column here. You can see it says project : and then the name of my project, CPB-project. You can see the same name in the folder at the top of the project column behind this window. So click Project CPB Project. To make sure things save in the CircuitPython board, we want to click on Project Structure. And then in the upper right-hand corner where it says Add Content Root, you'll see a plus sign there. Click that plus sign, and then a dialog box pops up. You want to navigate to the CircuitPy volume. That's our board, so your board should be plugged in. On the Mac, this should be in the leftmost column. You might have to scroll to find it. And when you do, click CircuitPy, and then click Open. And our project will now save Python code to our board. Cool. Now we'll set the specifics for the Python language for the project. Click Python Interpreter just above Project Structure. We need to select a version of Python that we'll use. You may only have one. Under the Python Interpreter pull down and select the version of Python that you just installed, which should be the latest version shown. Now, one last thing we want to do in this lesson, since this is a CircuitPython project, we don't just want to include basic Python. We also want to add the basics of CircuitPython as well. And we do this by adding what are called the CircuitPython stubs. So to add the CircuitPython stubs to our project, we click this plus sign to the left above the heading package, and this lists all the packages that we have access to, and there are hundreds. Now, you should see a bunch of options in the left column, but a bit of a warning. The first time I did this, it took about a minute or two before anything showed up. You might also try clicking this refresh icon to the right of the search bar. Remember, if things look like they're not working, quitting, restarting your computer, and restarting PyCharm may be the way to go. But there's a search field up here where we can find what we want. So in that search field, we'll enter CircuitPython-stubs. Notice as you type, the options will narrow down until just what we want shows up. And with CircuitPython-stubs selected, press the Install Package button on the bottom right of the window. It'll take a moment to install, then click Close, and in the Project Python Interpreter setting, you should now see CircuitPython stubs. In some cases, the CircuitPython stubs might not show up right away, but if you click OK to close the settings window, then get back into settings for the project and Project Interpreter, you should see that the CircuitPython stubs are there. Click OK, and at this point, we have PyCharm installed, we have Tio installed, we've opened up PyCharm, configured it, and we created an initial PyCharm project working with CircuitPython. Let's close out of PyCharm now. On the Mac, that's just Command Q, and you can press Exit. And I want to point out that the project folder appears empty, but I'll also show you how you can open that project back up. Now remember, we saved our project inside of the CircuitPython school folder, so I'll open that up now. And inside that we have our folder CPP project, the name of our PyCharm project that we created. And when we open that up, it's empty, as I'd mentioned. But there are actually hidden files in here. On the Mac, you can type Shift-Command period. That toggles hidden files between show and hide. We can see that there are a couple of folders in here, but again, we never need to click on these, so I'm going to Shift-Command period to hide them again. Now you might wonder, how do I open a project with nothing in it? Well, there are a few ways. First, we can open PyCharm back up, and by default, it opens the last project that was open. Now I can click the red traffic light in the upper left-hand corner to close the project window, and I can see my most recent projects are in the Welcome to PyCharm window. We only have one project, CP-project. I can double-click this to open it up again, or another way to get here, why don't I close this window first? I can head up to the File menu, select Open, then navigate to where my project is, which is on the desktop, in the CircuitPython School folder, and I can simply click the project folder's name, CP-project, click Open, the project opens again, and so now you know how to open PyCharm projects, so I'll quit out of PyCharm for now. And in the next lesson, we'll actually start to code. Keep at it, for the skills to make something awesome await those who continue.